Hey, let's go ahead and get started on our first lesson of the year, the basics and language of science. So every lesson I'll give you a series of learning objectives. By the end of this lesson, you should be able to define science, understand the relationship between math and science, define physics and the conceptual lens, and explore the different branches of science. So this, if you didn't already know, is Aristotle. Aristotle is considered to be the first scientist. For those of you who don't know who Aristotle is, I know none of you are philosophers, but Aristotle was a philosopher and a student of Plato. So the first people who began thinking about being a student and going to school, and that the world was bigger than what they believed it to be, and there was more to learn. These people are called philosophers. And Aristotle is considered to be the first scientist, not because he discovered anything and not because he practiced science, but he practiced techniques in logic, observation, inquiry, and demonstration, which are techniques that we still use today when we study science. This timeline is very long, but this is a timeline I created of science. The PowerPoint is attached to Formative. It's also available on Google Classroom. If you want, you can read about it, but basically this is just a little kind of timeline I use to talk about science, what it was, what it can be, and what it is now. So you can see, in prehistoric times, oral tradition, and as civilizations grew, they started using math, astronomy, and medicine and didn't even know that this was science. Science at one point was called natural philosophy. And then of course, Middle Ages, scientific revolution, 19th and early 20th centuries, how science became known in that world. And then of course, the rise in technology that has helped us practice science today. The only thing I want to highlight on this slide is science encompasses a huge part of humankind, and there is continuous research being done that is scientific. So it's not just one and done. It is continuous. It is ongoing. It is a huge branch of academia. To me, science is about exploration and experimentation and having fun, and learning new things every day. But go ahead, take a look at this timeline. You can pause the video if you want, or print it out and just have it with you. What is the definition of science? Remember, this is a learning objective. So science is the intellectual and practical activity encompassing the systematic study of structure and behavior of the physical and natural world through observation and experiment. So it's not only learning something, but it's practicing something that has to do with behaviors of things that we see, okay? And we do this practice by observing and performing experiments, asking questions about what we see in front of us, and then doing an experiment to kind of prove whether that's right or wrong, or what we're thinking is right or wrong. So science, you don't need to know the full definition, but as long as you know that it's something that we practice, you can say something about the structure of the physical and natural world. And then really, really important, you can just say branch of academia that studies the world through observation and experiment. Those two are really important. We can categorize science as well into three main branches. And the three branches of science are earth sciences, which is the study of Earth's structure, properties, and processes. And some examples of this are geology, which is the study of rocks, oceanography, which is the study of the ocean, meteorology, study of weather and things that occur in space that have an impact on Earth, In environmental science, how water pollution works and why that's affecting the earth in either a positive or negative way. Not pollution for positive, but other things that might be more positive for the earth, you would study in environmental science. There are biological sciences. I get a lot of jokes saying that biological sciences are much more fun than the physical sciences, but these are the study of living organisms and life processes. So things like biology, zoology, ecology, genetics, medicine, study of plants. These are all biological or life sciences. And then you have the physical sciences, and these are my favorite. These are the study of inanimate objects and the matter that makes them up. Okay. And of course, I used to be a chemist. I studied chemistry. I love chemistry and I love physics. So these disciplines include chemistry, physics, things like astronomy or cosmology. We could expand these three branches. I think this is pretty good for you to know: earth sciences, biological sciences, and physical sciences. Knowing some disciplines or some examples of each might be a little bit helpful too. Although these branches might seem very, very different, they're interdisciplinary, which means oftentimes some of the information that you might need in an earth science, you might find that information using physical sciences. In order to understand photosynthesis in biology, which is a life science or a biological science, you need to know the sort of biochemistry involved in that, and that's sort of a physical science. So as different as they may be, or as different as the information might seem, they're all connected and they're all interdisciplinary, meaning they all work together to kind of come up with the same goal, and that's to help us learn and to gather information within these three branches about science. So the language of science. I mentioned to you guys on the first day that there is a kind of a rule in this class, conceptual rule. But I can't talk about science without talking about the language of science, which is math. And I'll explain what this means in a second. Science is the study of nature. And in fact, nature can be analyzed and modeled. And when nature is analyzed or modeled, it makes making experiments a little bit easier to verify or disprove. And what I mean by analyzed and model is basically doing math. When we do math, when we use numbers, when we do equations, that's basically analysis and modeling without knowing what it is. So anytime you put a number into something, or anytime you use an equation, that's modeling, and that's analysis using numbers, okay? So you know this as equations. We often use equations to understand scientific principles, okay? And this is a big one here. I'm not going to expect you to do very high level math, but we should be able to do basic algebra. I'm going to work with your algebra teacher too to see what you guys know and what you don't know. But I'm telling you, it's so much easier for me to say things with equations than it is for me to say things in words sometimes. And I'll give you guys an example right now. This is my favorite example I ever gave. There is a equation in physical chemistry, in the realm of physical chemistry, that basically describes speeds of gases that relate temperature, mass, and velocity. So if I tell you that James Maxwell and Ludwig Boltzmann created a probability distribution for describing speeds in an ideal gas that relates to temperature, mass, and velocity, then that's amazing. But we can't really practice science just by utilizing this information. And I know this might sound a little strange to you. And again, I'm going to give you some numbers right now. They don't look very pretty, but this is Maxwell-Boltzmann's distributions of speed. So if I solve for mass, temperature, and velocity, it might make solving this function a little bit easier, and it might make our experiment easier to disprove or to prove. And I know this is like really high level. This is one of my favorite equations. But this is really, you could replicate their experiment if you were given this equation. So math and science kind of go hand in hand. I'm not going to give you anything this complicated. I just wanted to prove a point. But we want to be really comfortable when we see numbers. We want to be able to organize those numbers as best as we can, and you know, be able to feel comfortable replicating experiments. It is no secret that we live in a technological world. So both science and technology aim to improve human enterprises, help people, and play a role in their everyday lives. Science is responsible for asking theoretical questions as a way of knowing and explaining. Why is the sky blue? Or why is the grass green? This is a question that science would ask. When technology kind of goes in a different direction, it is responsible for building and designing usage for observing and solving practical problems. So very instant solve versus science, which might take a little bit more time. But again, we can't have technology without the innovations that we have in science. This I got right from the textbook, this kind of comparison of science, religion, and art. And I absolutely love the way that they put this. And I'm just going to read it to you. Science is different from religion and art because it is a process of discovering and recording natural phenomenon, things that we see, things around us, things that happen that can be proven scientifically. That's a process, discovering and recording it. Whereas art is valuing human interactions as it pertains to the senses. So we look at a painting, we write something down, or we draw something, and that's, you know, still giving us some kind of emotional reaction, but it really pertains to the senses. And religion is, you know, like all three of these, determining some kind of source and purpose and meaning. But religion is really specific when it's the meaning of everything in the broader world. So a little bit, I mean, they're all intertwinable, and it's really important that we're able to talk about these in a professional way and see them as different branches of academia that might relate in some way. And last thing I want to talk about is physics. Some of us might have different definitions of physics, but physics is the branch of science concerned with the nature and properties of matter and energy. Okay, everything is made up of matter. In order for anything to occur, we need energy. So a lot of the times we're going to be explaining things in a very broad way that might be focused on something specific. Physics expands to principles about inanimate objects, space, atoms, and power. So we are explaining not only objects, but we're going to try to explain what's going on in space, what's going on at the atomic level, which is very, very, very small, and how the things around us work, and how we give, you know, energy to those things having power. Physics is practiced using a variety of techniques. So some things that you'll do in class are observe, build, measure, simulate, demonstrate. You're going to be doing a lot of that over the course of the year. And then over the course of this class, we will study a composition of atoms, electricity, magnetism, light, sound, heat, and energy. We're going to do a lot. It's going to be really, really fun. And of course, we're looking at all of this through the conceptual lens, meaning we're not going to get math heavy. We're going to focus on those concepts and make sure we understand everything about atoms before we throw in the numbers. And I think that it works very, very well for an intro class. So thank you so much. There's some questions for you to answer. I hope you have a great rest of your day. See you soon.